the scanning of machines, trying to get more privilege to do more insidious things. And then this is a lot easier to do when you have a real-world software deployment, for reasons I'll discuss during the course of this presentation. And then crapware. This is a new term that's come up. Whenever you buy an OEM machine, a laptop, or you buy a computer or desktop, you have all those little tray icons, all those things are installed. All those things are just chock full of problems. So by having those there, you're inherent risks right when you install. And for those of us that aren't security experts and don't reinstall immediately or take them all out, everyone else is vulnerable to issues in these pieces of software. And then the funnel effect, which is what I call in the 90s, we moved attackers were attacking remote Unix software and go after its access control. And we had to shift towards, kind of happened slowly over 5-10 years, towards client software as people started closing down security holes. The attack surfaces shifted to areas where it was easier to find security holes, right? And the masses are always going to follow those trends. And I think we're going to start seeing more of a trend where we're going to attack local privilege escalation in operating systems. When Microsoft or Linux or OS X finally gets it right and gets that separation layer for usability on the web and the browser and then in the system, we're going to have to escalate privileges or not me, but attackers will have to escalate privileges to perform the steps they necessarily want to do. This is an overview of kind of what we'll talk about. This is a breakdown of the object manager, then the directory that's used, and this is all, but we'll discuss more later. Security controls in place, and then a technique to compromise systems that's somewhat unknown, and I'll go in depth in it and some new things that we found. And then a tool that I've designed and written that'll be available on the ISEC site that you can use to find these issues and remove them from a system, or find the software that has these issues and then potentially remove the software, I guess. So the object manager. What is the object manager? This manages all the objects in NT. Files, sockets, all these things. Not necessarily sockets, but register keys, LPC ports. All the objects in the kernel are managed by this component. It supports named and unnamed objects, so you can give an object a name for reasons why I won't talk about later. And of course, you have per process tables that the whole handle tables of currently open objects. And that's all tied together with the object manager. It's also, as I mentioned before, one of the most undocumented pieces of the Microsoft Windows operating system. There's a brief section in Windows internals that talks a little bit about it. That's about it. If you do a search, you won't find anything else. And it's a very large component for having no documentation. What is an object? Here's an example list of the ones people have seen all over the place. But virtually, I think there's 36 object types. They're there. So these are just a small snippet of the ones that you see. There's a lot of them that are in the kernel that you don't see very often. Here's some of the routines that the kernel uses to work with objects. To query, create object types. An object type would be like a file. And you can insert objects in the directory, which we'll talk about more. You can query for an object's name, given a handle or a pointer to it, to get the object name. So say I have a handle to a registry key. I can do a query for that and get the key. Some of those things. It's a little more trickier than that, but that's the general idea. Get object security. You can get a security descriptor, which has the DAC-all and a lot of the permissions associated with that object. And then you can open the object by name. You return a pointer or handle, the inverse of what we previously talked about. The problem is a few of these are exported. So if you want to write a driver or a component to work with these, you can't really touch them. You only have a couple you can access. I think it's one of the reasons that's not really documented. There's not a lot you can do to talk to it and work with it. Now the object directory. So most APIs offer a parameter like the create event, create file, or create shared memory, all these things. You have a name parameter, or you give it a name. Those of you who develop software have seen this frequently. And this name is placed in the object directory. That's used for lookups and correlation. It's also used primarily for IPC mechanisms. You go and create a mutex or an event with a name, and a process, B over here, can open that and signal it and set it and work with it, right? Without that name, you just have a handle. You can't really talk to it. Handles in the per process handle tables, like I mentioned, they have their own numbers. It's completely different than another process, for example. So that naming scheme, you wouldn't have much to work with. So here's the object directory. This is a snapshot taken from WinObj. This is a system internals tool that's been around for quite a while now. And you can see that the basic layout of the object directory, it's kind of like a file system in a sense. In fact, you have directories and you have names and you have a hierarchy there, and these have permissions and types associated, like a file system. But it lacks a lot of things like a file system, which we'll talk more about. But here we can see base name objects, which I'll talk more about as a key one. That's for global objects. And we have RPC control. All your RPC interfaces in Windows store a control endpoint there, which isn't really another thing that's not documented. A lot of these aren't documented. Windows are for Windows stations. You have your current sessions. So you have two people logged onto a machine, for example, terminal services. One will have an ID, maybe one, that'll be in there and have its own directory of objects. Another guy logs in, it'll be maybe two, and the directory of objects, and on and on and on. Known DLLs, these are preloaded DLLs. The system loads at runtime, and they'll copy those over as you need them on write. So they don't load them once. So a lot that goes on in the object manager for the performance of the system. Also, like whenever you go type C:// all that resolution for the drive name, the labeling is all done here too. And you see there's really strange paths in Windows where you have a C:// you have short UNC, long UNC. Some of that stuff is done in drivers in the system, but a lot of it is in the object manager. A lot of really awkward things you can do. There's actually symbolic links in here that loop around. They're circular if you're not careful. So you can create links that go back to themselves. It's really odd stuff. Choosing a name. So you prefix with global or local. As I mentioned before, there's global or local namespaces. And they have this little blurb in there that you can't insert a / character, right? Which whenever I see that kind of gives me an irk. Like I know that's being inserted into a control channel. Like you have format bugs exist. So when you combine data and control data together in one channel, and by parsing that, they can be parsed in a certain way and cause changes in the operation of that data. It's always a bad idea. And when you warn people, that's kind of an indication that they haven't figured out a way around it. So they specifically cannot use it, right? So it reminded me of this website I saw a few weeks ago. So that was kind of funny. It's actually on a banking website. Yeah, that gave me a lot of faith. I didn't have any faith in the banking community to begin with, but this just kind of compounded my fears. So, local object. As I mentioned before, they reside in a session / the number, the session ID, and then / base name objects. So if I create an event, like let's see here, with the name ISEC event, that'll be placed in /session /n or /1, for example, / base name object / ISEC event. That's where it's going to be stored in the hierarchy. And global objects, it's just / base name objects. So you follow the pattern here, right? Each session has their own kind of containment, their own area for objects. Here's a global prefix. Now, if you notice, let me back up. This path is automatically placed. This object's automatically placed in my session. It's important to note that. I don't define that or specify it, or can I even control that? So the object manager directory. I talked about this briefly, but I'll iterate more. There's the global objects up there, and here's an example name of what would happen if I ran that function. Right, it'll create that object and base name objects and the sessions. There's one down there. So session isolation. In theory, these directories 1, 2, and 3 different session directories are isolated, meaning user A cannot cross boundaries into B or C. That'd be really bad if that were to happen for obvious reasons. This is one of the things we'll talk about, obviously. So I'm trying to quote everything I talk about because there's a stance from Microsoft that it's supposed to be this way. So I'm going to go with it's supposed to be this way, and maybe if I can show why it shouldn't be that way, then things will be fixed. So namespace instances, as I mentioned before, a little bit of a caveat there. Session 0 is for services. It'll never be assigned to a user. That's you think about UAC and these separations, a lot of them are done with a sessioning scheme. You see here. So directory security controls. So the tool called Access Check, which is a great tool, again, written by Mark Rusinovich with systemterminals. You can run this on processes, files, registry, and search all of them for DACLs that are weak in Windows. This is great when you have a new application you want to deploy in your network, or you're reviewing an application, doing an audit. You can immediately you can do one before, then install it. You can diff that and get what's called a footprint, right, of what's been put in place. You get an idea of all the things that were introduced. For this purpose, I'm just showing directories. You have a couple here that are read-write, RPC controls, and base name objects for global objects, right? So this is an important privilege in Microsoft Windows. That actually, I didn't know about a lot of these until I dove into this the last 6 months. So bypass traverse checking. What this means is you have a hierarchy, right? You have directory, let's say A, B, and C. And directory A doesn't allow access from anyone besides system. And directory B doesn't allow access from anybody besides system. But C allows access to everyone to read, and there's a file in there for read. Now the idea, you think, well, maybe the person shouldn't be able to read it, right? Because the top level directories have this permission set. The hierarchy is set to deny, right? But when you enable bypass reverse checking, that's turned off. So if I create a file in the bottom directory on SMB or registry or anything, it's allowed by everyone. That whole top hierarchy is ignored. It's been like that since 2003, apparently. You can't even disable this check in Vista, Windows 7, or 2008. It'll just break. Well, you can disable it, but if you log in, all your services will fail and shut down. But it's there. So it's an interesting thing to know about, especially for IT security in general. Continuing. So another comment. This point you believe it may not be a security problem because of inheritance. So the concept of inheritance is when you have an object with permissions. Any child object of that, say it's a directory that has admin privileges, right? And any file created in that will inherit the permissions of the parent. The problem is when a directory is created secure at the top, say users for a large company, and you want to add a directory of permission for anyone to write to a directory, you have to turn off the inheritance or remove them. So you have to be able to edit the changes. And by doing that, you no longer have inheritance. So by saying that, it goes against the principle of bypass reverse checking and the principle of creating an account. Does that make sense? You have to turn this off to change the privileges. And when you turn it off, it's off. And bypass reverse checking is there now. So there's this kind of untalked about issue in NT of access control. That's kind of been assumed for a long time. But if you go and check that and you work with your own file system, you'll see that when these things are in place, it causes major issues. So you want to be very cautious of that, I should say. So as I mentioned, object creators often add explicit permissions to enable IPC. It's not like a file system with inheritance. When I create an object, I explicitly define who should read or write to it, right? Because that's an IPC. Usually, quite often, you're going to define permissions for that. Now, another thing that's interesting is while the object manager directory shares a lot of NT file system characteristics, there's no inheritance actually built into it at all. I can't find it. I've double-checked this in the last several weeks, reverse engineering everything in the object manager. I haven't found anything with inheritance, any support for it. So that's out the window too. So you have bypass reverse checking, not checking directory layers, and you have no inheritance. So for the most part, a lot of your access control is out the window. Anyways, you're creating it because it looks important. Which is a shock. This is all there. Deliberated religiously with my coworkers over this to prove all the theories and thoughts and created examples, which I'll do one for every single big claim that I make. So for namespace traversal. So in this demo, we're going to demonstrate that you can walk across a namespace boundary and access other users' objects with the way it's built, just the way it's built in the object manager. So I have a VM setup, VMware. Image running Windows Vista, currently patched, updated. Let's see here. And these are not zero-day issues. They're bugs in the operating system, but I'm not releasing something that I hope people can maliciously use, or hope they cannot. That'd be a Freudian slip. That'd be bad if that was. Okay. So we're going to create a local section, just a share. I'm going to call it test. It's just going to read data from this memory and write to the screen, so I can, when I'm writing to it and toying with you, I can see. And what we're going to do is go into our object manager here, and we should see in session 1 or 2, let's see, base name objects. We can go down to test. It's not there. I think I'm actually, as admin, I can see all the directories, obviously. Should have a test in here. There it is. So what we're going to do is emulate an object with permission that's low down the directory in someone else's session, right? Say cool find search engine or Google toolbar or something, or Ask toolbar, one of these things, right? Creates an object in your session, and you're assuming that the session environment around that will protect that object from another user. So let's remove this. This is an old account, it's stale. We're going to add everyone. See that barely. Okay. I'm going to add write to it, read. That's it. So now I'm going to switch over to my limited user, and I'll show you the privileges of that user. And goldfish. He's trapped in his little goldfish bowl, trying to get higher privileges to get out of it. Okay. I haven't had a lot of sleep. All right. So sections app is a simple tool I wrote. So I'm going to pass in. Let's back up. We'll do sessions. Was it 2 or 3? 3. I'm glad I got you guys here. And then test. Oh, basically I'm objects was the. Okay. And test. We're just going to zap with 5,000, 3,000 bytes. There we go. Let's get a little more because that buffer I think is actually 2,000. All right. And also, who am I? I should run that. I don't have any special privileges here. I've got, let's see, bypass reverse checking. It's enabled by default, all accounts. Interactive group, authenticated users, this organization. I am a limited account. No admin privileges whatsoever, basic account. Okay. And now we'll switch back over. So it's string copying data into buffer, mem copying. So I've corrupted that across session namespaces. Now, the reason this worked is because the APIs will limit you to only your local object. But that, when I called that section zapping, it just called directly into an NT function, right? Passing it directly into the kernel through an interrupt without checking all those parameters. So I can access direct pass in the object manager. So here's an example. It's still breaking a couple times. All right. So what does that mean? Any application that creates an insecure object can be accessed. If it's accessible by everyone, anyone in another session namespace or a compromised process of any degree service can traverse over and read and write to that. So I ran some tests and needed some OEM software. And none of the advisors or anything are ready today. But there's quite a few products out there affected by this issue that allow an automated escalation of privilege to administrator. OEM stuff with Crapper is just a nightmare. Because you have products that are shipped out, hardly tested, but they may not even have source code coming from outsourcing. It's just passed on, shipped in. Still these problems with rootkits and some of these devices and a lot of that. It's all from the same kind of Crapper idea. You have the software coming in, no one checks it out, and they put it on a machine, right? And when OEM's involved, it's a lot of money, right? So you get this kind of issue. You have to be careful with it. Now, object security controls. There's ways to set an object security, which is called the DACL, the list of what are called ACE entries. Every account, you put an account in there and an access or deny, and you can list those entries, and that's called a DACL, right? Ultimately in Windows. You guys have probably heard that 1,000 times before, but just in case. So you can set these on an object after it's created or when it's existing. Set kernel object security, private object, user, just the type of object and what you want to set. So, what's interesting about this too, another variation of kind of attacks on objects, is that when you set after it's created, programmatically you don't really see this, but there's a small recendition there between when it's created and when it's changed. So if you create it with a default DACL that's insecure, it allows everyone, and then restrict it, 3 functions later, an attacker can write a tool to probe for these objects and then compromise them in that small window, right? That's the same idea of creating a file and a shell script and then gmoding it later. It's all over the place. So that's always have a small window when you can race in and jump in and take it or override it or whatever you want. In the case of a global namespace, it's a lot more likely an attacker can see these. So objects are governed through security descriptors. As I mentioned before, the DACL is part of the security descriptor. The other things are kind of erroneous and not mainly for this talk, but the owner and grouper, I guess, important too. So what else? So most of the APIs allow you to supply your own SD, let's say a security attribute or a creation attribute. And if you look closely, it says security descriptor. There's a lot of code out there to create your own. And if you have trouble finding it, I can send it to you too. But you can create a security descriptor and apply that. Maybe even use it as a utilitarian library for your product and just make everybody use that descriptor, right? Or even set the default DACL for the process, not even worry about it. Everybody will create using that from now on. It's very easy to solve these problems. Whereas, you're less 10 lines of code, and all the objects there are secured. If you don't supply one, then the DACL is taken from the primary token of the process owner. So what's called your default DACL, which on modern operating systems, at least modern NT, is administrator, system, and the owner of that process. So if it's administrator, you're usually pretty safe for most parts. You get back into XP and some other systems, things change, right? So you see this panel all the time when you're configuring objects in NT. Nobody has ever written this in their products. This is a common interface called Edit Security and Create Security Property Page, and they just call this. This is the same thing. What's interesting about this is it's a generic set of permissions for each object. When every object has their own permissions, their own giant subset that are set, you can't touch any of those here. So I think it's interesting. It's all hidden from you. And because this is so nice and clean, people just reuse it everywhere. And a DACL, which we've talked about, I think at this point, everybody gets that. So, yeah, it's a common practice that instead of creating a default DACL, you take the existing one. So the process, you get that from the token, and you add an entry to it for like everyone, for example, and then you use that. That's kind of how people do things. So this is really interesting with default DACLs. And another thing anyone's really touched on before. So when someone creates this default access control for an object, for an application. Now, imagine a scenario where there's an RPC service that your favorite CD player software installs, and it sets set default DACL to allow everyone, but it's loaded inside the SVC host generic process. And every object and every system process in that will now create objects with poor permissions. So another thing, or like an Internet Explorer plugin, or toolbar, or Firefox, or any other application. So we use define and protected objects, like an access check, and if you download that, you can check it out. I think this guys have some samples how to run it in different applications and different types of objects to find weaknesses. Unnamed objects, this is kind of interesting. So certain unnamed objects in Windows are actually forcibly named, even though you don't declare a name, you don't want them to be named. They're named anyways. And they're accessible, too. They're accessible globally. So I went and dug around in RPC runtime, and I found where they create the name. They just generate a random number, 9 digits in length, and that's the name. And if you saw earlier when I had that RPC controls and that directory view, if you click on there, you see all these random names. And those aren't special controls. They're things that people created, not intent to be accessible remotely or locally by their applications, maybe besides a known app or trusted app, but they are here. So you can query those with remember Todd Saman with the BindView wrote a tool called IFIDS a while ago. But you can feed an endpoint and query it. And those are all the interfaces listening on the endpoint. Another thing to remember is that if an object's already opened, no matter what you change to that, it's not going to change those open handles, right? So it's a common. You can't do it with file systems. You can't do permission checks on read and writes. I mean, performance would skyrocket problems. You can only check on open and close. So the same thing for security. When you apply it, it's applying it for future opening operations. So there's a connection to a file or name pipe in place. For whatever reason, it's not going to apply to that. That's kind of common knowledge, I guess. But so object squatting is another interesting way of escalating privilege. I think it's to work on anything with a global registry for objects along those lines. So first, let's go into some privileges. There's a couple here that are important to know. This SE create global privileges, or a privilege, is a privilege that was put in place to prevent people from creating shared memory in the global area. Because apparently there's been problems with this, right? Because you can create a shared section of memory, have someone else use it, and obviously it's going to cause a problem if you have names of directories or functions to call or things. Data structures are there, rather. If you're in session 0, the services, session, you can do that. But you can still create all the other object types that are there. It's just an interesting thing to know about. It's there. Symbolic link privilege, another one. Only admins have this privilege, so you can't create symbolic links. So the reason I lead into this is you see this kind of patchwork that's been done. Not a global solution, but this is a problem, let's add a token here. This is a problem, let's add a token here to access this over and over. And each time a new one pops up, you add another feature, right? Not a general solution, but for these. And that I would imagine because so much of the software out there relies on the way it works, you can't change the access control model. Everything would break. This is a key part of the operating system. Yeah, as I mentioned here. It's like LPC ports, pipes, events. There's a whole ton of objects. We got 2 there out of 36, right? So it's a lot more to work with. So object squatting. Non-administrative users, as we know from our permission check before, can create objects and base name objects and RPG controls. So a rogue user can create an object that masquerades as a legitimate object with the same name, because the authentication doesn't exist. It's done by name for identification for that object. You can disrupt users, potentially escalate privilege. Who knows what else? So I'm going to demo for this one as well. So what I've done is I took the DNS resolver built into Windows, and I decompiled the IDL stub code out of it into an IDL and fixed it up, and then rebuilt it into a fake DNS resolver, right? And I'm going to run this as a limited user with no privileges. In theory, my object should be created in RPC controls because I can write to it. And I'm going to advertise interface there, and callers will go to that object, and they specify what's called a connection sequence, name pipe, endpoint, local RPC, and RPC. It'll go to my name, which is DNS resolver, and then go over to my process and a notification of who I am. So let me switch over. These 2 sessions get me confused sometimes. I'll have to switch back and forth. Okay, there we go. So, my own DNS service here. This binds the resolving or creates my own resolving endpoint, advertises it, and waits for people to do a lookup through the endpoint mapper or somehow call that protocol sequence and come through to me. So I'll switch over to my administrator session again. And now if I do a ping for like google.com or anything, oh, it's just completely broken. Let's see here. Uh-oh, that's not good. Let's switch back over and see what's going on. Yeah, it turns out that faking RPC service with my own IDL has been challenging, at the least. Oh, it's getting a request, though. Here, so we can see this coming through. For some reason, this doesn't decide to work. Let's do this. We'll do a run as. There we go. Oh. I was translating to Riley, that's right. This name aliasing is so frustrating in Vista. There we go. All right. So let's try here. We'll do a ping for google.com. This is administrator. See, they're routing through for some reason. DNS resolver. I think I've just broken it so many times now that my machine has just threw it all together. Let's see here. Okay. Well, I think one of the demos. Can I flush it? I gotta love that. Okay. Well, so my demo failed. I knew it was going to happen at least for one of these. But you guys can see how it's communicating with the endpoint. It's just my poor ability to process structures coming in, apparently. That's causing a failure here. It's worked every day but today. Okay. Object squatting and impersonation. So this is something else that's interesting. The SE impersonate privilege in Windows won't allow you to impersonate people calling into your code, right? Unless you're a higher privilege. This is done, if you guys remember, At Stake did. Actually, Andreas Junson, one of the guys at ISAC. This is back, I think, 6-7 years ago. Found you could knock down a service and then create a name pipe, the same pipe as a service, like I think LSAS was one they did, And then when someone connected, you impersonate that person. And it'll be the system user a lot of times, right? That was a major fix to one is SE impersonate privilege. Generally, because when you have that privilege, you can compromise a machine, no problem. Because I can do that same attack I just did, but I would impersonate administrator. Even if that failed because of my packet parsing in that sense, I would still acquire their token. So it's pretty nasty. Now, on Vista Enterprise, in this example, those are the accounts that have that privilege. Okay, ASP.NET, local service, network service. What you'll notice is those are accounts that are on the outside of all the server applications. They were given these permissions that were lower for a reason. So you can get local system when someone exploited an IIS system, right? Or MSSQL, they're all given these privileges. But they have the SE impersonate. So if you compromise one of these processes, you can impersonate RPC control or something else that's there, and then impersonate that way. And that goes against the model they currently have, so I don't know how that would be fixed. Here I kind of mentioned that a little bit more. You also have the SE create global privilege. That makes it easier too, so you can create shared memory and other objects that are restricted when you have these lower accounts. So it's interesting to think about those are the kind of the two checks that are in place that prevent you from escalating easily. But because they've been there for so long, all the software relies on them. So once you realize you have them and use them, it becomes more dangerous. Yeah, and today kind of NT land, the general assumption is if you can get SE impersonate privilege, you can become system. There's just so many avenues that have not been fixed or cannot be remediated. They're just done from access control. Once you have that, you get one of those accounts. Another interesting kind of tidbit here. So mutex objects, when those are created, it doesn't matter if there's an object already there with that name. They'll just use that. So you can create a bunch, and then they'll come and just use yours for mutexes. Which it's not a whole lot you can really do. I mean, you have events and some stuff that happen. You can trigger maybe application will check to see if it's an application is listening before it accesses shared memory or calls RPC, so you can signal that and got to do certain things. Or you can keep a firewall from loading, but all that's trivial stuff. So protecting yourself. So you want to tighten the DACL at creation. Set a default DACL for the process. Create a library or utilitarian class or something people can use with your software or software of companies you work with that will restrict these. Solved. You have to go through and spot fix all these things in the code. You just do it one place, and in the back end, it'll use that by default. When it inherits, it'll inherit from your secure object. You need to assess DACLs and a previously owned software configuration. Things like file systems you can use the tools to search for. Giant SMB file systems for corporations we've seen are a mess. But you can use something like that to just run overnight and find all the problems. Find corporate projections that are open to everyone, that kind of thing. Let's see. All right. The last thing is private namespaces are really interesting. So I think this is Microsoft's solution to solve a lot of the problems that I've mentioned, and probably maybe not some of them, but maybe more of them. Who knows? It's a very interesting concept. Unfortunately, it's only in Vista and Windows Server 2008. That's the one problem. But the way this works is you create think of it like a barrier. It's basically a private prefix. Say I create secure or company name, whatever it is, right? Company. And I give that a boundary description where I attach certain people to it, certain accounts in the system. They can access this new prefix. You have local and global. You have one called Acme Company / the object name. From that point on, only the people in that group can access that. It allows you to create your own custom prefixes. And they're also hidden from the object manager, so you can't see them. Only way to see these things is to get into the kernel and put breakpoints in the table access and look in there. So it's kind of interesting. The problem is it's only in Vista for now, so for software vendors, obviously, they need to support XP, and that kind of change is somewhat problematic. Some tools. Application Verifier is a tool, a Microsoft development tool you can use to validate a lot of code that you're working on for, memory leaks, handle leaks, all sorts of cool stuff. There's also things in there for object squatting. For example, if you're creating objects in a way that are, in global namespace, that kind of thing, will warn you about them. To a degree. Not really how helpful it is, but it's informational. WinOBJ is a tool that I just used to kind of peer around and look at things. Access check I'd mentioned. And then Object Trace is a tool that I wrote actually to help solve some of these problems. So it allows the tester to monitor creation of all system objects and local objects susceptible to squatting or compromise. Implemented via the Object Manager callback in Vista. there's a new callback implemented in SP1 that you can hook in and monitor certain events in the NT kernel. The problem is you can only look at processes and threats. It's made for antivirus vendors and whatnot. But there's just a flag. If you look at the routine and the kernel that creates this, it's just a flag. So I don't know what it is at the document. It's just 40. And you go and you flip that in the type. Now you can monitor all the objects. So they haven't enabled that publicly, obviously. But it gives you can create a pretty powerful tool using those. So hopefully this works. Good grief. All right. Let's switch over here. Okay. I'll switch back over to my administrator mode. You guys have any questions so far at all? I've kind of skimmed through pretty fast. Yeah?
How do private namespaces stop name squatting? Why don't you just name squat the private namespace?
Because you can't enter that namespace unless you're one of those SIDs.
No, but why don't you just create the namespace before the other people try to create the namespace? And when you
See,
go into the namespace, how do you know the namespace wasn't created by somebody?
that's actually a good point. If you created one with,
I don't understand.
if you created one with the same name previously, that'd be, I don't know. I think they're also tied to the boundary descriptors as well, though. Those are attached to the private namespace. So I think you have to have a matching boundary descriptor, if I remember. Yeah. Nice try there. I actually work with this guy. He's trying to shoot me down.
I'm not trying to shoot you down. I'm just saying that it's really the problem.
No, I think you're right. It's worth looking into. Okay, let's get back to this. All right. So object trace. God, I hate UAC more than anything in the world. All right. So let's run this. So it goes and gathers objects that are being created live by applications. So it's probably more useful for finding security holes right now than it is for testing your software. But what it allows you to do is you can pick one of these objects. Say we have files here, keys, sections, anything. And I go into the kernel and do a backtrace. So you can see exactly where these objects are created. So at the least it's neat because you can see exactly where an RPC endpoint is created in the system. You have to dig around through DLLs all day and night and try to figure out where it is. Right? It'll grab exactly where it is. Dress it up with symbols for all the objects as well. And you also have security privileges for all of them. I list all the object privileges associated with the object that are here. I don't stick to the read, write, and the controls. I show all of them because there's things like key all access, create link, subkey, enumeration. These aren't, a lot of them you can't set, right? Some of them are even undocumented. So it's kind of interesting. You can see some permissions that may allow you to do more than you think they would that are there, right? But you just don't see that edit security tab that's been used for the last, 10 years. What else? So we can also have concept of filters here. So I create a filter for, say, object type equal to any account, and I'll pick, let's pick everyone. Has any privilege. And I can highlight, exclude, or include. I'll say I only want to include them. Add a rule, apply it. Now I only have objects that have everyone privilege on the whole system. It's kind of like doing an access check across all the undocumented functionality in NT, right? So for example, this is interesting. Some of these root objects, like the root hard drive, the root drive directory, and these have access to everyone. And that's, of course, as everyone, you can go in the root directory and create a folder called test. It's kind of strange. But you have privileges like that people don't really know about. I can create a software directory and, for example, / program, application company name, and put my stuff in there. And then when they overwrite, it'll fail and maybe create symbolic links. I don't know. It's kind of strange. It's just that way. So, and you have search functionality. You can search and hit highlighting all that stuff. This is available on ISAC's website if you guys want to check it out sometime. That's on the slide deck here, actually. Yep. ISAC Partners, tools. So conclusion. So we often make assumptions about these systems, and one of the reasons I started this project is everyone telling me there's no problems in this, it's been hard, it's been used for so long, and I like to go after those kind of projects because those are the ones that if you spend enough time on, you find strange nuances and issues and problems, and there are some there in this case. Most applications create objects in a way that's not secure. So It's kind of interesting to think about the escalation possibilities. If we start going that direction, this is going to be a mess. Escalation in Windows isn't really talked about, and I don't know how well it's known, but you can escalate from privileges fairly easily if you have a real live system. If you're on a base install, yeah, there's not a whole lot there to work with. There's a couple of things, I'll tell you, what I found, but there's not that much. When you deploy real enterprise software on it, it's over. It's a mess because of all these problems with objects. And then the crapware problem, all this third-party advertising software, it's the same kind of effect, right? You're just throwing software at a machine. It's not locked down. And yeah, these can be used by attackers to exploit even hardened systems. It's amazing. I went through and I ran this test on my machine, and all the tools that I have, all my plugins and all these things create these objects, right? It's funny. They all create. I think a machine that's a lot of softace on it, and the Mega had open RPC endpoints, that anybody can access remotely. It's just amazing what's there, right? So thanks, Jesse Burns, Scott Sender, and Brad Hill. They work heavily on a lot of projects that involve knowledge of internal NT technologies. So it helped me kind of test out the permission issues and research them to make sure that all the claims are valid. Andreas and Ginyang for peer review and testing object trace, going through all my drivers. Steve for holding my hand through icon creation, which is actually much harder than I thought it would be. It's one of those mysteries of the world. As our building and designing an interface, which I thought I've always strayed away from. I've written command line tools for 15 years. And I've never written a rich interface to handle all the events. And there's like 40,000 lines of code. I almost jumped out my window a couple times. So I kind of apology to all my friends who are bill engineers and interface designers that I said their job was silly. I was wrong. Their job was very hard. Questions or comments?
I actually wanted to talk about private namespaces again.
Okay.
So I'm curious, and this probably comes from my ignorance with NT in general, but my experience with private namespaces and other operating systems like 99 and Linux and BSD now is that they're actually just creating a namespace or a container for everybody's individual objects. And in Unix, of course, that's temp file systems or drivers. Yeah,
proxy system, yeah.
Is that the same thing that they're implementing?
It's the same kind of concept, and then the solution is further isolation,
Okay.
right? And it's kind of interesting when you see a trend in a group where they reapply the same ideal, but just deeper and deeper and deeper. And after a while, they realize it's not a good idea. They back up, and all that 10 years they wasted on development, they re-architect. And for this, you have to re-architect a little bit, I think. Some things have to change. I mean, the fact that it's a file system like this behaves like a file system, they should have more controls like a file system if they're going to do that. The isolation of objects, if they're local objects, they shouldn't be anywhere. They shouldn't be in any database or anything that's exposed to the outside. It's not local. But they're putting local objects in a global repository, right? Make something that's also public to anyone. So the idea that they have to just kind of rethink a couple of things. I don't think they're massive changes. I mean, maybe they are. I would assume they would have been fixed by now, but.
I kind of have a follow-up. I'm sorry to hijack this, but the only other question I have is, I may have missed this as well. Are directories themselves made objects and put into this?
Directories, so you have the concept, when you think of files and directories in NT, these are actually all a file object that goes into basically like a driver interface. Each object has a set of routines to parse to deal with that object for security checks, for parsing, and for handling. For example, a pipe is actually a file. It's just a special file name that's interpreted by the endpoint. It parses that out and treats it as a different kind of file. It's a special file. So you hear about special files in NT, it's because it's really a file object type. And that driver that handles it, or filter in this case, treats it differently. So as far as directories, there's two kinds. You have a directory as far as the file structure, which is treated the same as a file. And you have a directory in the object manager, which is a directory object that's different. There are some differentials there, so it's not the same. As far as difference, I think it's just type and the kind of content that's there. I mean, I think mainly it's just for organizational benefit. That's about it. The security really doesn't apply as much as we've seen, but it helps organize things, right? Instead of having one big bucket of objects.
Okay, thanks.
All right, that's it. Sorry about the demo, guys. Maybe next time.